All right, hello and welcome. Today we are diving into something that sounds, well, a little intimidating. Exploratory factor analysis. I know, it's a mouthful. But trust me, by the end of this, you're going to see it's basically a superpower for finding simple, clear stories hidden inside messy, complex data. So, let's jump right in. Okay, so let's set the scene. Imagine you've done all the hard work, right? You've put together this great survey, you sent it out, you got all your responses back, and now you're just staring at this massive spreadsheet. It's got like 20, 30, maybe even 50 columns of data. And you just look at it and think, okay, now what? What on earth does all of this actually mean?
Yeah, if that scenario makes you feel a little bit overwhelmed, you are definitely not alone. It's a classic problem, right? Information overload. We've got this mountain of data, and our job, our whole goal, is to find the real, meaningful story that's buried somewhere in there. But where do you even start?
And that really gets to the heart of the problem we're trying to solve here. How do we take all those different variables and shrink them down into something we can actually wrap our heads around? Something manageable, something understandable, and here's the key part, without losing all the important stuff. Well, especially in fields like psychology or sociology, we're often trying to measure things that are kind of like ghosts. We call them latent variables. These are the big ideas we really care about, but we can't measure them directly. I mean, think about it. You can't take a ruler and measure someone's burnout, right? You can't put intelligence on a scale. So what do? We measure a whole bunch of things we can see and hope that together they point us towards that hidden concept. And this brings me to a quote I absolutely love from the statistician Andy Field. He just nails it. He says he became a living, breathing factor analysis. He took a mass of information he didn't get and filtered it down into a simple message he could get. That's it. Factor analysis is a filter. It takes this big, confusing cloud of data and just boils it down to its essence. And that, my friends, is our solution. Think of factor analysis as your own personal statistical detective. Its entire job is to comb through the crime scene, your data, and find the clues. It looks for all your variables, figures out which ones are moving together, and groups them into these underlying themes, these hidden patterns. It's all about cutting down the noise and finding that secret structure. Okay, so how does this detective work its magic? How does it actually find those hidden patterns? Well, it all starts by looking at how every single variable talks to every other variable. It all kicks off with this thing right here, a correlation matrix. It looks complicated, but it's simple, really. It just shows you how strongly related every pair of your variables are. A 1 means they're a perfect match. So, what are we looking for? We're looking for cliques, for clusters. Check out those high numbers in bold. You can see that Talk 1, social skills, and interest are all hanging out together. They're highly correlated. That's our first gang. And then look down a bit. Talk 2, selfish, and liar. Yep, they form their own little group too. These clusters are our first big clues. And each of those little gangs, those clusters, they're pointing to something bigger. They're pointing to what we call a factor. A factor is just that hidden underlying thing, that latent dimension that's making all those variables move together. So in our example, maybe that first cluster is really all about sociability. And the second one, maybe it's tapping into something like consideration or maybe self-interest. Okay, so we've found these hidden factors. Awesome. But that's not the whole story. Now we need to figure out exactly how strong the connection is between our original survey questions and these new factors we just uncovered. And that brings us to the key idea of factor loadings. But wait, hang on. Before we do that, we have to answer a huge question. How many factors are actually real and meaningful? We don't want to keep junk factors. And for that, we have a super useful tool called a scree plot. All this does is graph out how important each factor is. You can think of it like a ranking of which factors explain the most about our data. And you see that shape? There's that big, steep cliff at the beginning, and then it just flattens out into this pile of rubble at the bottom. That shape is a massive clue. And we usually use a couple of simple rules of thumb to make the call. The first one is called the elbow test. See where the plot makes that sharp turn, like an elbow? We basically just keep everything before the elbow, all the stuff on the steep part of the cliff. The second rule, called the Kaiser rule, is even simpler. It just says keep any factor with an eigenvalue, that's just a fancy word for its importance score, that's bigger than 1. And what's cool is that a lot of the time, both of these methods will point you to the exact same number of factors to keep. All right, so now we know how many factors to keep.
Now we can finally look at those factor loadings. And a factor loadings is super simple. It's just the correlation between one of your original survey items and the hidden factor. That's it. So a big, high loading just means that question is a really, really good indicator of that underlying concept.
But here's the thing. When you first run the analysis, the results can be, well, a total mess. You'll have variables that seem to be kind of related to factor 1, but also kind of related to factor 2. It makes it almost impossible to interpret. So how do we clean up this mess and get a clear story? This right here is what I'm talking about. This is what the results often look like at first. You can see how some of these questions have decent-sized numbers on more than one factor. It's not obvious which group they belong in. It's like a blurry photograph, you know? You can kind of make out the shapes, but nothing is sharp, nothing is distinct. The solution? It's an absolutely brilliant little trick called factor rotation. And voila, this is the after picture. This is what it looks like after rotation. I mean, just look at how much cleaner that is. It's night and day. Now, every single variable has a really high loading on one factor and practically 0 on all the others. The blurry photo is now perfectly in focus. The pattern just pops right out at you. It's so obvious.
Now, there are basically 2 flavors of rotation you can choose from. The first is called orthogonal. This one forces your factors to be totally independent, totally unrelated. You'd use this if you think your underlying concepts are truly distinct, like, say, math skill and artistic skill. The other flavor is oblique. This one is a bit more flexible. It allows your factors to be correlated, and this is really useful when you suspect your concepts are probably related in the real world, like anxiety and depression often are.
So where does that leave us? After all that detective work, what have we actually accomplished? Well, we've gone on a journey from total complexity to beautiful clarity. And now we have a much simpler and honestly a much more powerful story to tell. So let's just recap the whole process real quick. Step 1, we started with a big, complex mess of data. Step 2, we found the hidden factors by looking for clusters of related variables. Step 3, we used rotation to clean it all up and make the pattern crystal clear. And now we've ended up with a simple, easy-to-understand structure that actually tells us something meaningful.
Okay, but why should you care? Why does any of this matter? Well, factor analysis is super practical. For one, it helps you actually understand the deep structure of a complex idea, like what brand loyalty or employee engagement is really made of. It's also absolutely essential if you ever want to build a good, reliable survey or questionnaire. And maybe best of all, it lets you take a massive data set and boil it down to just a few important scores, which makes everything you do afterwards way, way easier.
And that, in a nutshell, is exploratory factor analysis. It's this amazing tool for finding simplicity in a complex world. And it leaves me with one final question for you. Now that you have this new way of thinking, this new lens for spotting hidden patterns, what unseen factors do you think might be quietly shaping the world all around you? Thanks so much for joining me.